Integration by parts. Lesson 69. So we have a new integration rule to look at today. Excuse me. This integration rule, the idea of it is it's essentially a product rule for integration. You know how we have a product rule and a quotient rule for derivatives. Integrations are a little bit different because you're working backwards. But integration by parts is a specific way we can integrate when there are products. When there's two different things and use substitution isn't going to really cut it. So, the setup you need to know is right here. And the idea is, it's the integral of u dv is equal to uv minus the integral of v du. So, the starting piece, we will separate into u and dv, and we'll have to pick those out. Once we pick out what we want to use as u and what we want to use as dv, we can then find u and v, and we can fill in our formula here. So the formula we'll be filling in is this part right here that is uv minus the integral of v du. Okay? So every problem we do today, I'm going to be kind of setting up a box here. Just easiest way to think through it. We will always want to pick out what we want to use as our u and what we want to use as our dv. Okay? Whatever we want to use as our u, you have to be able to nicely and easily take the derivative of. Excuse me. Whatever we want to use as our dv, in order to get up to v, we're going to have to be able to integrate. Okay, so you're going to pick one thing you're going to take the derivative of, the other thing you're going to take the integral of. Knowing what to pick when is just, there's kind of a learning curve there. You get a little bit better about it the more we practice with it. And I'll give you some tips and stuff, things to think about as we go. Okay. Excuse me. Example 1 is asking us to integrate. It's the integral of x sine x dx. Now, do you understand why we can't just do this as is? There are two pieces here, yes? There's an x and there's a sine x. You can't just integrate them both side by side and that is your integral. Okay? Just like you can't just take, if we were trying to do the derivative, you can't just take the derivative of x and the derivative of sine x. You have to use a product rule. Same idea here, and we're going to use integration by parts to do this. So the integral you are looking at right now represents the beginning part. So the integral of u dv. And I will try and keep my u's and v's unique. Okay, so that's what that piece represents. We have to pick out one piece that is u. So pretty much u is either going to have to be the x or the sine x. It's one of those two pieces. Okay? The dv will be the other piece along with the dx. Okay? So u, we want, whatever we do for u, we want it to have a nice neat derivative. Whatever we do for dv, we want it to be able to integrate relatively nicely. Okay? And one of our things you'll figure out today is if what we pick doesn't work to begin with, then we'll flip-flop and try the other way. Okay? So I'm going to kind of set up the box in that here's u, here's du, here's v, here's dv. And as I said earlier, the two we're going to pick out are u and dv. Okay. Well, if you think about sine x, what do you know when you do the derivative or the integral of sine x? Right. It's either way, it's going to end up being cosine x, right? Well, it's just going to be a matter of whether it's positive, negative. So that one, I mean, we could do derivative or integral of that pretty easily. What about the x? Okay, if you take the derivative, that's going to look a little prettier. Not saying we couldn't do the derivative, but then you're going to end up with that 1/2 x squared. Okay, so and again, and I'm just going to kind of essentially tell you guys as you practice these. But so with that in mind, let's pick the x to be our u part, and then the sine x, and yes, officially the dx, will be the dv part. Now, one comment I will make, can you count on them always being in that order? No. Okay? So, if I write over here, what do we pick u to be? X. dv we pick to be sine x dx. Notice, is everything accounted for my original problem? Yes. Okay? So, to get from u to du, you need to take the derivative, yes? So the derivative of u is du. What's the derivative of x? Just 1. Now, since it's in terms of x, you're going to have to tag on a dx. So 1 dx, or if you guys will, I'm just going to put dx. Now, we know dv. How do we get from dv to v? We have to integrate. So what is the integral of sine x dx? What is the integral of sine x? Yeah, I always have to think, okay, cosine, and work that way. However you think about it. But so my v is going to be negative cosine x. And since we are integrating, that dx is gone. Okay. Are you good with what I filled in there? Because now we're going to go over here and we're going to fill in our formula. Which our formula I'm filling in is uv minus the integral of v du. So, uv. You have that in your box, yes? uv is going to be x times negative cosine x, which can be written as negative x cosine x, if you're okay with that, minus the integral of v. What's v? Negative cosine x. And then it's du. What did my du end up being? Just a dx. Okay. Can we work with this? The negative x cosine x is just there. That's part of your answer. Can you integrate what ended up in my integral? So can you integrate negative cosine x? That's doable, yes? Okay, so we have something that we can work with. Success here. We just have to finish it off. Negative x cosine x is going to stay negative x cosine x. Minus, what is the integral of negative cosine x? Negative sine x. And here's, so I kind of play with it in my head. The derivative of sine is cosine. So the derivative of negative sine would have to be negative cosine. Now, this is an integral I just took, yes? The whole thing was an integral. Do I have boundaries on this integral that I can plug in? No, so what do I put at the end? Plus c. So, if you haven't already cleaned it up, you can clean up the minus negative. So negative x cosine x plus sine x plus c. questions? Okay, should we try example 2? Okay, example 2. The integral of natural log of x dx. First of all, I don't know if you guys notice or not, but all it's asking us to do is the integral of ln x. Sounds easy enough. Do we know the integral of ln x? That's not the integral, though. That's the derivative. We know the derivative of ln x is 1 over x, but do we know the integral? We do not, which is why we can use this integration by parts. So I'm going to set up my box, u and du, v and dv. And which two parts do I have to assign something to? U and dv. What are you thinking here? Nope, you only use the ln x in one place. There's a definite place the ln x has to go on this one.
But the dv would be dx. Yes.
Yeah. Why does ln x have to be the u? Yeah. We can take the derivative, which is what we'll do to u. If you make it dv, can we take the integral of it? No, that's the whole reason we're in this boat, right? So we're going to say u is the ln x. And in this case, there's nothing left other than dx. So kind of a unique case. It doesn't happen like that very often, except in this one. So my dv is going to be dx. Okay, can you complete your box? The derivative of u is du. So what is the derivative of ln x? 1 over x dx. I know a lot of you guys tend to leave those off, but those little du's, dx's, they're important notation. Now, how do I get from dv to v? You integrate, right? So dv, this is like 1 dv. The integral of 1 something, 1 dv is just going to be the v here. So the integral of 1 dx, what's the integral of 1? That's just going to be x. Can you always check yourself by going the other way? Yeah. If I take the derivative of x, it's going to be 1 dx. Okay, do you remember what you're filling in? uv minus the integral of v du. So what's uv? uv is, okay, ln x times x, which better written is going to be x ln x. Okay, glad I don't have to integrate that. Minus the integral of v du. What's v? X. What's du? 1 over x dx. So I just used my box here. So x ln x is still x ln x. Clean that integral up before you integrate. What is x times 1 over x? Just the dx. Or if you want, you could think of it as 1 dx, right? Because x times 1 over x is just 1. So now, what is the integral of that 1 dx? Or what is that integral of that dx? Just x. So I'm going to have x, ln x, minus x. Final answer? Okay, x ln x minus x plus c. Okay. Got questions? Okay, example 3. We're going to integrate x e to the 2x dx. And again, I'm going to set up my box, u and du, v and dv. And you know at this point, you have to pick out what we want u and dv to be.
So you read that.
It is. Does that just feel right to you?
Yeah, since doing it the other way would be a little more.
Yeah. And I was trying to decide if there's a good, yeah. Some of you just kind of have to figure out as you go. Okay, you'll get the feel for it. But Wade suggested to make u the x part. And I agree. Okay. Trying to think if we were to flip-flop this, if it works. And I don't think it would work. I think it would get too ugly. So now, if u is going to be x, what does that mean dv is? It is everything else that's left. So it is e to the 2x dx.
On the first problem, was dv sine x dx?
Yes. Did you not have the dx?
No, I forgot to write that down. That's fine.
Yeah. I wrote several dx's in on the test where people just, I don't count off anything. I don't know if they count off. Like, it would only matter on the open-ended questions. I don't know the free response questions. I don't know if they count off if you know, because that is an important part of notation. I don't know. So, okay. So if u equals x, find du by taking the derivative, right? The derivative of u is du. What's the derivative of x? Dx. This is the one that's a little trickier on this part. However, it wouldn't have ultimately worked well if you'd done it the other way. Okay. Integral of dv is v. Integral of e to the 2x dx. What's the integral of e to the something? It's the same, right? Now, what's the catch here? Yeah. If we were taking the derivative of e to the 2x, we're going to have to compensate because the derivative of e to the 2x is e to the 2x times the derivative of 2x. What's the derivative of 2x? 2. So that's if we took the derivative. We're trying to go backwards and do the integral. So what compensates for a 2? A 1/2. So that means we're going to say that v is 1/2 e to the 2x. Now, if you don't believe me, or that's not what I meant to say, if you're not sure of yourself, if you're thinking, I don't know if that's the right way, just write it down. take the derivative. What's the derivative of 1/2 e to the 2x? Well, 1/2 e to the 2x times the derivative of 2x is 2. When I do 1/2 times 2, they'll cancel, and that's where I'm at with dv. Okay? If we had flip-flopped our u and dv pieces, when we put this together, we'd essentially be doing the same integral here. Okay? Which is why you would quickly find out that there's one way that works and one way that doesn't. Okay. uv minus the integral of v du. So, what's uv?
1/2
Are you guys okay with that? I'll write it for the moment as x times 1/2 e to the 2x, but I'm going to have another line I can clean it up in. I like the 1/2 x e to the 2x. That's perfect. Okay? Minus the integral of v du. So that means I'm going to be doing the integral of 1/2 e to the 2x dx. So if you didn't already clean up the first part, x times 1/2 e to the 2x, I am going to put 1/2 x e to the 2x. Minus. Now, this 1/2 here. Okay, that's one way I think. And if you're there, that's fine. Do you have to concern yourself with the 1/2 right now? The 1/2, because technically that 1/2, if it's confusing to you, is a constant that could go outside of the integral, yes? So, and I agree, you're where you need to be. Yes, I agree with the 1/4, Jack, but I was making sure everyone gets there. So if we take that 1/2 out front, then all you're integrating is e to the 2x. So what's the integral of e to the 2x? Well, the integral of e to anything is e to that same thing, right? But we've already done this once. If you do the integral of e to the 2x, chain rule says you would have had to do the derivative of 2x, which is a 2. We are doing the integral, so we need to compensate, and there's going to be another 1/2 out here. Because that other 1/2 was already there. Does that make sense? And so if you kind of block that out, now we have just 1/2 e to the 2x there for that part. And then as always, I'm going to go ahead and write in. I'm going to write in a plus c. I'm going to clean this up a little bit. 1/2 x e to the 2x. And now, if you weren't seeing Jack's 1/4 earlier, you definitely see it now, right? 1/2 times 1/2 is 1/4 e to the 2x plus c. I am okay with this answer. There is also a GCF that you could technically pull out that would make the insides look a little prettier. Both terms have what in common? An e to the 2x. And technically, if you want to get rid of the fractions, the Gray's common factor, they both have 1/4 is a smaller common one. They both have a 1/4. So really you could pull out a 1/4 e to the 2x. And if you do that, you're still going to have the x on the first one. 1/2 divided by 1/4. Well, that becomes 1/2 times 4/1, which is 2. So you have 2x minus, the next one you pulled out the whole thing, so it's minus 1. So that's another acceptable way to write the answer.
So, like with this one, dv, we had, of course, 2 to the ex times dx. Then we wrote it down, we had the 1/2 x, or 1/2 e to the 2x dx. So we don't need 2 of them then if there's already 1. You don't have to like multiply it with that. Because we have our dx from the du, or it's just the one that I kept from the dv.
Well, but
Wait.
did you just answer? You're doing v du. When you go from dv to v, you lose the dx there. So there's no dx there. The dx only comes from the du.
Oh, okay. I was putting it wrong. Gotcha.
Does that make sense now?
Mm-hmm. Yeah, I was putting dv in instead of
Okay,
dv.
yeah. You have to use v and du, and du is where the dx comes from. And then v should not have a dx, because when you integrate it to get to v, you drop off the dx. So no, I didn't just randomly write 1 when there's 2, or yeah, you'll never have 2 of that though.
Gotcha.
Okay, example 4. Integrate x ln x.
X needs to be U value.
And why do you say that?
You don't have an integral of X.
Okay. So, can I show you guys something real quick? I would just want to kind of show you, because we haven't really worked any through where it's like, oh, that didn't work. Were you guys all going to pick U as your ln x? Or what's been the common trend? U has been X has been the common trend, right? If you pick that, let me just show you real quick that U is X, and if U is X, then du is dx, right? If you pick dv as the rest, you get dv is ln x dx. Now, technically, we do have an integral of ln x now. What do I mean by that? Yeah, technically, because of example 69.2, and again, it's still not going to work, but I just want to show you. We could use v, what was the integral of ln x? X ln x minus x. And that right there is from the example above, which is example 69.2. Here's how we're going to know it doesn't work, though. When you set up your uv minus the integral of v du, u is x times v is x ln x minus x minus the integral of v du. Well, look at what happens. What's v? X ln x minus x times dx. Can you pinpoint something specific that happens? I mean, it's ugly, I agree. But our whole goal is we're trying to do the integral of x ln x. What ended up in our integral? X ln x. So did that help me any? No. Okay, because we ended up with another x ln x right there. Okay, so I mean, your class wasn't as set to go with just the u as x, but I just wanted you guys to kind of see. That's kind of, you hit that point, you're like, oh, that's not going to work. I'm integrating the same thing that was the problem to begin with. We need to try something different. So, okay, real time through. Whether you wrote that one down or not, this is the real deal. We need a u. We need a du. We need a v. We need a dv. As always, you're picking u and dv. So, if u is not x and dv is not ln x dx, what are we doing? Flip-flopping. So that means u is going to be ln x. dv is going to have to be, what are my pieces then? Okay, if u is going over here to ln x, then we've got x dx left. And x dx is my dv. Okay. If u is ln x, what is du? Okay. The derivative of u is du. The derivative of ln x is 1 over x dx. Okay. If dv is x dx, I need to integrate. What is the integral of x dx? Yeah, it's a power, right? We haven't had to do that today, but you add 1 to the power, we're at x squared, divide by that, so 1/2 x squared. And now you should be set to go. Again, you're setting up uv minus the integral of v du. So uv, doesn't really matter what uv is because it all just goes together. 1/2 x squared times natural log of x minus the integral of v du. V is 1/2 x squared times du. What's du? 1 over x dx. It's not just dx, right? I knew what you meant. So often du has just equaled dx, but it's not. Du is 1 over x dx. Now, good news is those pieces multiply together. It's not going to be a bad deal. So cleaning up, 1/2 x squared ln x stays the same, minus the integral. Now, you guys okay if I say let's pull this 1/2 out front? If you pull the 1/2 out front, then what is x squared times 1 over x? Okay, x squared times 1 over x, and x cancels. You have x, and then we still have dx. Can you integrate x? Much better than we can integrate x ln x, right? Okay, so 1/2 x squared ln x minus, I already have the 1/2 here. What is the integral of x? Yeah, add 1 to the power and divide by the new power, so 1/2 x squared, and don't forget, plus c. You can clean that up a little bit, and then I didn't have my 1/2s multiplied. So 2 options. You could say 1/2 x squared ln x minus 1/2 times 1/2 is 1/4 x squared plus c. That's one option. Like the previous problem, is there a factoring thing you could do here? Yeah, both terms have an x squared, and besides having x squared, if we do the same fraction deal as last time, you could pull out the 1/4 and it'll make life nicer. So you can factor out a 1/4 x squared. Leaves me with, well, 1/2 divided by a 1/4 is 2, and then ln x minus, play out this whole thing, so minus 1, and then plus c. Okay? That is your integration by parts. Practice those tonight. Make sure you get a grasp of what you're doing there.